Hi students, welcome back. In this video, we'll tackle the LeetCode problem of valid anagram. Let's go over the problem statement first. So the problem statement says we are given two strings S and T. We have to return true if S is an anagram of T or false otherwise. How is an anagram defined? An anagram is a word or a phrase formed by rearranging the letters, which means that S and T will have the same letters and same frequency, but they will be in a different order. So let's look at the examples given. So we are given two strings, anagram and nagaram here. Clearly the exact same letters are used in both the strings. So this is an anagram. Whereas if you see this example, here RA are common between them, but here there is a T and here there is a C, which is why this is not an anagram. We are also given a constraint here saying S and T consists of lowercase English letters only. So we don't have to do the conversion to lowercase or removing special case characters, etc. We are guaranteed that they are lowercase special characters. So we will solve this problem using two approaches. The first one is called the array sort method. So let's go over the algorithm first. So let's say we are given two strings, listen and silent. So if they are anagrams, that means they have the exact same number of characters as well. The first thing we can do is we can check if the number of characters are same, and which is the length of the string. If the length is not same, then they can't be anagrams and we can straight away return false. Here the length is 6 in both the strings. So let's continue with the algorithm. So the algorithm says first convert the strings to character array. So once we have the character array, the first step is to sort them. So listen, if we sort, it would be E, I, L, N, S and T. Similarly, silent, if we sort, it would be the exact same characters actually. It would be E, I, L, N, S and T. Clearly both are same, both are equal. So this is an anagram. So after sorting, we are basically rearranging the letters in a certain way so that they are easy to compare. Once we compare these two arrays, it is very clear that they are anagrams of each other. Similarly, if we take a different word, let's say we are given two words hello and world. So hello, if we sort, it would be E H L L O, and world, if we sort, it would be D L O R H. Clearly both of them are not equal, so these can't be anagrams. Okay, let's go over the let's write code for this. Okay, so our first step was checking if the lengths are equal. If the lengths are not equal, they can't be anagrams, so we can straight away return false. Okay, if the lengths are equal, then we can create character arrays. Okay, which would be 2 char array. Okay, character array of the second input, which is t dot 2 char array. Okay, now we have the arrays. The next step is to sort them. Arrays dot sort first input, arrays dot sort second input. Now once they are sorted, this is an anagram if they are equal, and it's not an anagram if they are not equal. So we can just use the arrays equals method to check if they are equal. Okay, if they are equal, it's an anagram, so we can straight away return whatever array dot equals returns. Okay, now let's submit and see. Yeah, it got accepted. Time complexity of this solution is, the length check is order of 1, converting to character array is order of n, sorting is a n log n operation, equals is a order of n operation. So the heavy operation here is the sort operation, and that is the highest contributing factor for the time complexity. Okay, now if we look at the space complexity, length check again is constant. 2 character array, this one needs order of n extra space. Sort is in place, it doesn't require any additional memory. Compare is can also be in place, it need not require any additional memory. So the space complexity would be order of n. So the time complexity is n log n and space complexity is n. So let's look at how we can optimize this solution. So using a hash map, we can optimize the solution. But here our input is exactly English lowercase letters. So we need not create a hash map as such. What we can do is we can create a 26 character array and use it as a hash map basically. Okay. So let's say we have a array like this. So this is sequential. Just for representation, I have written it side by side. So this is 0 to 10, 11, 12, 13, 14, 21 to 26 letters of the array. Okay. So now we are given the input listen and silent. So what we will do is for one input we will increment the count and for the other input we will decrement the count. Okay. So when we are traversing, when we are at the first letter, we are at L in S. So at L, we will increment the count to 1. Okay. And for the second string, we are at S. So the count would be decrement, right? So it would be minus 1. In case of now we advance the pointer, both are at I. So here it would be Y 1 and the next one will decrement it. So this becomes 0. Essentially I became 0. Okay. Then next we would be at S and L. So we have to increment S and decrement L. So when we increment S, it's already minus 1. It becomes 0. When we decrement L, it's already at 1. It becomes 0. Okay. Next we are at T in first input and E in second input. So T gets incremented, E gets decremented. E becomes minus 1. Okay. Next we are at E and N. So E gets incremented, N gets decremented. E gets incremented. So minus 1 becomes 0. N gets decremented. There is N. So N becomes minus 1. Next we have N and T. N gets incremented, T gets decremented. So when we increment 1, it becomes 0. When we decrement T, it becomes 0. Okay, so at the end of it, our check is we see if all the character counts are 0. If they are 0, that means this is an anagram. Here if you see, everything became a 0. So the array is initialized with 0, so the untouched values will always be 0. Whatever we have touched, they have become 0. So these are anagrams. So what we have done, for the first string, we have incremented the count. For the second string, we have decremented the count. Both are of same length. So in the character array, we kept on doing it, and as long as at the end of it, we checked if any of them is non-zero. If they are non-zero, that means they are not anagrams. If everything is 0, they are anagrams. Okay, let's look at the second example with the same input. Okay, let's say we have hello and world. So when we start, we will be at H and W. So we will increment H. The first string we increment, second string we decrement. So we increment H, so H count becomes 1 and we decrement W. Okay. Then we will be at E and O. We increment E and decrement O. Increment E and decrement O. Okay. Next is L and R. Increment L and decrement R. Okay. Next is both are L. So resultant it becomes 0. Next is 0 and O and D. So we increment O. So minus 1 becomes 0. and decrement D. So D value becomes -1. So at the end of parsing, we have so many non-zero values, which is why this is not an anagram. So let's write code for this solution. Okay. So the initial check of length is still the same, but we are not converting them to character array. What we are doing is we are uh, creating a integer array which has the frequency, okay, and it is of size 26 because there are 26 alphabets in English. What we are doing is for int I equal to 0, I less than s dot length. We can take anything because we already did the length check. Both are guaranteed to be same. I plus plus. What we will do is in the frequency array, okay, we get s dot char at I. We get the ith character and we are subtracting it with the character code of A so that we get 0 for A, 1 for B, etc. So our array indices are from 0 to 26, right? 25, which is why we are doing a minus A. And for the S, we will do plus plus. Similarly, for T, we would do a minus minus. Okay. At the end of it, for F in frequency array, okay, if f is not equal to 0, that means there are some values or alphabets which are not same, we return false. But if we processed all the map and we are here means it is true. So what we are doing is we created a frequency map of 26 size. For every character at S and T, for S we are incrementing, for T we are decrementing. After finishing the processing, we are checking if um, any non-zero value exists. If non-zero value exists, then we are returning false. If everything is 0, that means both have the exact frequency of characters. So we are returning true. Okay. Now, if we check the time complexity of this solution, again length check is order of 1. This is a space operation. Here we are traversing the array or the length till the length of the string. So this is a order of n operation. Here we will be traversing exactly 26 times. So this is again a constant. Okay. So for if we check the space complexity, the actual space we are using is only these 26 characters, which would be, it is not a multiple of n, so which would be order of 26, which is nothing but order of 1. Okay. So here time complexity is order of n and space complexity is order of 1. It is much more optimal solution than the earlier one. Okay. Thank you for joining me in solving this problem today. If you found this video helpful, don't forget to like and subscribe. If you have any questions, please leave a comment and we will respond. Remember to practice more, keep coding and improving your problem solving skills. Happy coding! See you in the next video.